So in continuation to our lectures for analysis of determinate trusses, we have here another sets of examples using method of joints, and probably will introduce later on another examples for method of sections and method of substitution. But for now, reviewin natin kung ano yung na-lecture natin from last meeting. What was our lecture from last meeting? That was basically the review on your method of joints. Kasi as much as possible, dapat matapos natin yung today's example para makapag-quiz na kayo or makapag-problem set na kayo sa Saturday. Or on that note, o nga pala, sa Saturday, tayo sa continuous example. So for instance, if I have this particular truss system, random, gagawa tayo ng truss system as shown here. Random lang. Random lang ako. Then let's just say I have a hinge at this joint and a roller on this joint. Okay. Nakikita po ba yan ng maayos?
Yes, sir.
So for instance, in this given problem, una natin gagawin is of course to identify the joints within our given truss system. So for that, ano yung mga joints natin? Let's just say this is your joint A, B, C, D, E, F, G, and H. So those are our joints with this particular truss system. So first things first, before we solve any of the parameters, the reactions, ang tawag na dito, the number of the reactions, the forces on each members, the tawag na doon, the applied forces and all that is of course to determine whether the given truss system is indeed a determinate type of truss. How do we do that? By using our formula. Ano yung formula natin with the degree of determinacy of a truss system? Para dire-diretso, sige, mag-recite. Wala. What is your number of reactions plus the number of members is equal to 2J, such that if that is greater than the 2J gives us an indeterminate truss. But if it is less than 2J, we have an unstable truss system. So with that note, bilangin natin ilan yung number of reaction within the given truss. Ilan yung ating number of reaction? Ano yung mga nandun? We have a hinge at joint A and a roller at joint E. That is horizontal, vertical, si hinge. Then, vertical, si roller. We have RE and AH and AV. Okay? Then, number of reactions is basically 3. Number of members. How many members do we have in this particular truss system? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Tama ba? Bilangin nyo rin ha. Number of joints. We have A, B, C, D, E, F, G, H. 5, 6, 7, 8, 9, 10. Okay? Tama ba? Binilang nyo? How many reactions? 3. How many members? 3, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8. Mali. Yung joints, there are how many joints?
8, sir.
8.
Sir.
Okay? So, by using this formula, again, you'll then have to solve for the degree of determinacy. So, how do we identify that? R plus M is 3 plus 13 equal to 2 times J of 8. That is 16 equal to 16. Therefore, the given truss system is indeed a determinate truss. Okay? So, determinate truss yung ating given problem. So, number 2, how about if you're now given this particular truss? Random lang ako nagdo-drawing ha. So, how about, ay mali. We have this truss system. Given that it has also a hinge and a roller support. Identify again your joints. A, B, C, D, E, and F. And of course, count the number of reactions at the identified support, which are at joint A and E. How many reactions are there in the hinge support? Again, there are two. We have horizontal and vertical, and only one for the roller support. Okay? So counting the number of reactions, that is 3. The number of members, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. About 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 members. How about the number of joints? 1, 2, 3, 4, 5, 6. We have 6 joints. Then, using our formula, R plus M is equal now to 2J. Substituting all known values, 3 reactions, 9 members, and how many joints? Those are 6 joints. So basically, that is also 9 plus 3, 12, 2 times 6, 12. That is also a what? Ano siya? Determinate, indeterminate, unstable.
Determinate truss.
So this is now also a determinate truss. So what if, sulitin natin yung examples para wala kayong masabi. Number 3, what if we have a truss system as shown? Pasensya nyo na, hindi pantay. Basta kayo na mag-drawing na maayos mamaya. Given the supports on the given truss at joint A as a hinge support and another hinge support over here, a roller support on this joint and another roller support on this joint. Again, pag ganyan lang yung binigay na problem, nasa sa inyo na yan to plot off your own joint values or your joint variables. So meron tayong internal hinge cross bracing. So hinge joint connections. Okay? Identifying the joints. We have A, B, C, D, E, F, G, and H. Nakuha po kung paano nakuha yung joints.
Yes, sir.
Plotting off your reactions. Identify that joint A that we have a hinge, a roller at joint F, and a roller at joint E. Again, there are two reactions at hinge support. You have your AH, AV, a vertical reaction at a roller support. Your RF, and another roller at joint E of RE. Okay? So with that, again, counting the number of reactions. Kakaplat lang natin, meron tayong 1, 2, 3, and 4. We have 4 reactions. How many members? Those are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 members. So how about joints? We have A, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 joints. Okay? Using our formula again in determining the degree of determinacy of a given truss, that is R plus M equal to 2J. Number of reactions plus the number of members equal now to 2 times the number of joints. So 4 plus 15 is 19. 2 times 8 is 16. Therefore, R plus M is greater than 16. Tama?
Yes, sir.
Greater than 16. Giving us the notion that this is a indeterminate truss. Remember, baka sabihin ninyo masyadong scripted si sir, random po yung truss, wala akong hawak na kahit na ano. So lumabas yan na indeterminate truss. So how do we identify now if the questions is the degree of indeterminacy of the given truss system? Basically, that is R plus M minus 2J equal to the degree of determinacy. Okay? So R plus M is basically 19 minus 2J of 16 gives us positive 2 degree. Therefore, the given truss system is now twice or 2 degree of indeterminacy. Or basically in the second degree of determinacy. So the given truss here is on the second degree of indeterminacy. And as our last example, number 4, random ulit. Such that it has now a roller support at both ends. Again, identify your joints. Then, plot your results. The number of reactions, members, and joints. So, para mas madaling makita, i-plot nyo na yung reactions at each supports. Joint A, AH, and AV. Joint C, we have RC. So, basically, there are 3. Ay, wala pala. That is both roller. So joint A is a roller support while joint C is also a roller support. Okay? So the number of reactions this time is only 2. The number of members have 1, 2, 3, 4, and 5. Okay? Number of joints 1, 2, 3, and 4. Computing the degree of indeterminacy. R plus M should be equal to 2J. That is 2 plus 5 equal to 2 times 4, which is 7 equal to 8. Is it equal to 8? No, of course it is. R plus M is less than 8. So if that comes out, therefore this is now an indeterminate truss. But at what condition? So if 7 is less than 8, let's try that again. R plus M minus 2J equal to the degree of indeterminacy or the degree of determinacy. That is 7 minus 8, which is basically negative 1 degree. Pag negative yung degree of indeterminacy natin, ano ang condition? This is now a, kung nakikinig kayo last time, this is now a, what? May nag-recite, nawala. Nasaan na yun?
Sir, unstable trust po ata.
Ata. Grabe naman yung ata na yan. So, of course, this is now a unstable truss. Okay? So, yan na yung magiging answer natin. So, look for the degree of indeterminacy of the given truss system and identify the classification and its degree of indeterminacy or unstable. Ganun lang naman po yan. So, those are some examples in determining the degree of indeterminacy or the degree of determinacy of a given truss system, whether they are a simple truss, a compound truss, or a complex truss. So on this given example, ano sa tingin ninyo ang simple truss? Problem 1, 2, 3, or 4? Ano dyan ang simple truss?
4, sir.
And ay, hindi Ano ba ang condition natin sa simple truss, compound truss, complex truss? Simple truss is solvable by the method of joints and method of sections. Okay? Where method of joints considers the first two unknown members connected by a joint. Method of section can be easily solved, trusses that are solved by dissecting three members, more or less three members. Ano ang simple truss dito? Basically, simple truss are those trusses that are then identified as a determinate truss, where having joints that are having members that are connected, having two members connected by one joint. So ano dito yung mga truss na merong two unknown joint members? Ay, two unknown forces on a member. Those are, ito yung ating magiging simple truss, and another simple truss. Then this one is a indeterminate truss. Hindi natin siya pwedeng isolve by method of joint dahil meron tayong joint, merong three members lahat ng joint connecting more than 3 members or more than 2 members. Can you perform method of joints with joint A? Can you perform method of joint at joint A? Can you? No, of course. At joint G. Hindi rin. So, more or less, this particular truss system is now either a compound or a complex truss. So if it is a compound truss, we will then have to try to solve this by method of section, dissecting members, maximum of 3 members, or method of substitution by removing one member from its position to changing the joint connection, then returning it later on after you have solved the reactions. Okay? So with that note, let's try to solve an example problem. Okay? Pili kayo dyan sa apat. Maliban dun sa number 3. Kasi ibang example yan. Pili kayo dyan sa tatlo. Yung 1, 2, and 4.
1, sir.
Sigurado? 1? Napakadali ng 1, oh. Pwede natin isolve. Sige, 1. Pili natin yung 1. Dagdag ko na lang mamaya yung 2. Mas masaya yung 2 eh. 1. Pangit. Wait lang. So, parehas ba? Yeah. Then, we have already determined from this example that this is now a determinate truss, right? Again, identify your joints. B, C, D, E, F, G, and H. Okay? Ngayon, kayong bahala Anong gusto nyong load? Saan nyo gustong ilagay? Dead load and live load lang tayo. Concentrated. Yung uniform load, sa susunod na, ang tawag na dito, sa steel and timber nyo na lang. Or sa influence line diagram. Saan nyo gusto ilagay? At anong direction nyo gusto ilagay? O, magbigay na, dali. Binibigyan ko na kayo ng chance. Go! Kayong bahala magbigay. Tayo solve natin. Awan? Awan, mangitid. Random. Kahit sabihin nyo, dead load. Magbigay kayo ng dead load. Concentrated. Saan nyo gusto ilagay? Saang joint?
Joint C, sir.
Joint C. Anong direction? Upward, downward?
Downward.
Sure ka? Sige, downward. Joint C. Dead load. Anong value? Dalian nyo, maubusan tayo ng oras. Hello?
10 na lang, sir.
Ano? Anong value? Type nyo na lang kung ayaw nyo magsalita.
Ten daw, sir.
Sure? 10. Oh, let's just say that is 10 kilonewton. Isa pang dead load na naiiba. Parehas lang naman yan dun sa isang example eh. Isa pa. Joint F, upward, downward. Joint H, upward. So, hayaan nyo na lang yung orientation na upward, downward. wala namang upward na dead load eh. Pero syempre, for the sake of solving and challenging yourself, of course, lagyan natin ng upward. Ano ilalagay? 4? Tama ba? 4 kilonewton? Sa joint F, ano yung gusto nyong ilagay doon? Dead load na upward, downward?
Upward, sir.
Upward din. Okay. Anong load? Anong load?
Sir, 15.
Sige, 15 kilonewton. So, yan ay bottom member. Let's just say that is your roof truss system. So, meron tayong ceiling load. Maliban sa dead load na yan, let's consider a ceiling load, CD. Ilan ang gusto nyong ilagay na ceiling load? Thickness 12 mm, 0.008 times 12 mm. Let's just say, tawag na dito. Let's just say 0.008, 12 mm, 0.096. Let's just say meron siyang tributary width na 5 by 6. So let's just say we have a 3 kilonewton ceiling load, tributary area. Then more or less nagdagdag tayo ng live load kasi nga roof truss. So meron tayong live load dito na sabihin na natin 2.5 kilonewton. Okay, but in some examples, you can also determine that there will be a dead load and live load both at point B and point D. Pero gusto ninyo na dyan yung ating load, so dyan lang natin ilalagay. Okay? May gusto pa kayong idagdag? Live load. May gusto pang idagdag?
Wala na po, sir. Okay
Wala
po
na.
yun.
So kung wala nang idagdag, wala tayong earthquake, wala tayong wind load and whatsoever, more or less the maximum load combination should be a dead load plus a live load. Okay? So isa-mate na natin ito without considering LRFD or a reduction factor. Yung eksaktong value yung gagamitin natin. So 10 plus 2.5 gives us a total load of 12.5 kilonewton. And later on, randomly, more or less, pag nagbigay ako ng examples at pag nagbigay ako ng exams, maglalagay ako dyan ng horizontal loads. Maglalagay din ako ng incline load. Lang, para lang ma-challenge. Lalagay ako ng incline load at an angle of such, then the equivalent force. Then, pag ganyan ang example, kunin nyo lang yung horizontal, vertical component. Ganun lang yon. Okay? So, ito yung ating example, maximum load at joint C considering load combination of dead load, live load, 12.5 kilonewton, such that the live load on the ceiling section at the bottom members of the given truss system, wala namang live load sa ceiling, di ka naglagay ng storage sa yung roof truss, so basically 0. Live load is equal to 0. So, summation, 8 kilonewton. Ay, 8. That is 18 kilonewton and this is 7 kilonewton. Okay? Ngayon, lagyan natin ng parameters, length of each members. All bottom members and web members, web and top members, horizontal, vertical, horizontal and vertical members are 6 meters steel section. Halimbawa, lumabas sa analysis natin na meron tayong double angle na D4 or 4 inch by 4 inch of 3/4 inch thickness. Hanapin nyo na lang yung ASEP steel handbook na yan. So, meron tayong 6 meters sa lahat ng bottom members, top members na horizontal, and vertical web members. Okay? So 6, 6, 6, 6, 6, 6, also 6, and another 6, and 6. Then the rest will be a 1:1 of square root of 2. Lahat ng inclined and diagonal web members. 6:6 is simply 1:1 of square root of 2. Tama ba? Tama?
Yes, sir.
So 1:1 square root of 2. 1:1 square root of 2. 1:1 square root of 2. As much as possible, kung hindi pa kayo sanay mag-solve at mag-plot ng truss details kagaya nito para sa inyong truss analysis, kumpletuhin nyo muna yung mga parameters, the length of each members, the hypotenuse, the number of joints, the dead loads and live loads, and so on and so forth. Okay? Then, of course, do not forget the reactions. Kung ano yung orientations ng iyong reactions. Initial assumptions natin should be in positive axis. So, upward AV and to the right AH. Then, the roller should also be upward RE. Okay? So, first things first is for us to solve, of course, the reactions at the support. So, sana nakikita. Okay? The reactions at the support. So, anong gusto nyo? Joint A, joint E. Saan tayo magsa-summation moment? Sige, go, interact para madali nyong maintindihan.
Joint A, sir.
Joint A. Sige, summation moment at joint A equal to 0. All clockwise motion, positive. Okay, what are the forces that we can moment about point A as shown in the given figure? Ano yung pwede nating i-moment sa joint A? Those are applied forces, dead load and live load, and their equivalent summations. Then the reaction at joint E. Okay, moment of the load found at joint C towards joint A. Gaano kalayo yan? Gaano kalayo ito papunta kay joint A? That is, how far? Horizontally.
12.
12, sir.
12. So we have a total load at joint E directed downward towards point A. That is 12.5 kilonewton clockwise, counterclockwise.
Clockwise po.
Clockwise. Positive, negative.
Positive.
Of course, that is positive. Clockwise towards point A, 12 meters. What are the other forces? We have the vertical load at joint F going upward. Wag seryosohin yung denotion na upward ha. For example, purpose lang po yan. Wala tayong dead load na pataas. Liban na lang kung lift force. Pag aircraft analysis naman na po yun. Ano yan? Upward going point A. Gaano kalayo? Gaano kalayo?
6.
6. Clockwise, counterclockwise. Counterclockwise at 6 meters, right? So, counterclockwise minus total load 18 kilonewton towards point A of 6 meters. Meron pa? That is the vertical load at joint H upward going point A. Gaano kalayo? Yan. That is 6, 6, and 6. 6 times 3, 18 meters. Clockwise, counterclockwise. Of course, counterclockwise towards point A. So that is negative what? 7 kilonewton. Gaano kalayo? 18 meters. And lastly, of course, as we have assumed, the vertical reaction at roller joint E upward going point A counterclockwise. Gaano kalayo? That is 6, 6, 6, and 6. 6 times 4, 24. Counterclockwise, positive or negative?
Negative po.
So, minus RE of 24 meters. To set it in equilibrium, kailangan nating equate yan to 0. Simplify. Get your own calculator. 12.5 times 12. That is 150 kilonewton meter. 18 times 6, 108. 7 times 18, 126. Then 24 RE. Simplify. 150 minus 108 minus 126. That is negative 84 of negative 24 RE. Equal to 0. Transpose 84 to the other side of the equation. You have 24 RE equal to 84. Divide both sides with negative 24. That is RE of negative 7.2 or negative 3.5 kilonewton. Negative 3.5 kilonewton. Therefore, our assumption at the reaction at the support of joint E roller should be then going downwards. So palitan natin yan. Reaction RE should be downward of 3.5 kilonewton. Kahit hindi nyo na i-carry yung sign, basta binigay ninyo yung arrow as downward. Bakit downward, sir? Yung dati mong example, positive naman yan. Note, you have included an uplift force found at joint F and joint H, which signifies that there are bigger dead load at the bottom section of the truss system than of the top section. Kasi 12.5 yung nasa baba, nasa 25 kilonewton. So obviously there will be an resisting force of reaction 3.5 directed downward to help the applied force at the top member. So ating reaction at the roller support should be then downward. So yan na yung ating reaction RE. Then by investigation, wala namang horizontal. Walang tayong in-apply na wind load. So basically, summation forces horizontal is equal to 0 going to the side positive. What are the forces found at the horizontal axis within the truss system? Meron ba? Wala. So basically, AH is simply equal to 0. And of course, all of the applied forces within the truss system acting only at the vertical axis. So, how are we going to do that? Solve the vertical reaction at the hinge support. Upward forces, positive. What are the vertical forces on our truss system? At joint F, there is basically an 18 kilonewton upward, so positive. Joint F, a 7 kilonewton upward, so also that is positive. Then at joint C, we have a 12.5 kilonewton, which is going downward. More or less, that is now negative 12.5 kilonewton. And do not forget the unknown AV upward. So positive AV equal now to 0. Always do not forget to equate to 0 to set the system in equilibrium. Okay? So, eto ngayon yung ating summation forces vertical. Nailagay ko ba lahat ng vertical?
Sir.
Yes. Simplify. 18 plus 7 minus 12.5. Yung sumagot ng yes, hindi nakikinig. Kulang ng alin?
Yung RE, sir.
Yes. Which is upward, downward? Downward. Kasi negative 3.5. Equal to 0. Substitute 18 plus 7 minus 12.5. That is 12.5. Parehas. 18 plus 7 minus 12.5. 12.5. 12.5 plus AV. RE was identified as 3.5 kilonewton going downward, equal to 0. 12.5 minus 3.5. That is 9 kilonewton. AV is positive 9 transposed to the other side, negative 9 kilonewton. Therefore, AV or vertical reaction at the hinge support should be downward. AV, downward. That is 0, 3.5. This is 9 kilonewton. Downward. Okay. Investigate. 9 plus 3.5 plus 10, which is 22.5. More or less, it should then resist the uplift force caused by the dead load found at joint F and joint H. Di naman necessarily na dapat equal sila, no? Plus 12.5. Ay, 25. Parehas pala, oh. So, tignan ninyo. Reaction at the hinge in the roller. 9 plus 3.5, 11.5 plus 12.5. 11.5 plus 12.5, basically 25. Tama ba? Yeah, 25. No, 12.5 plus 12.5 pala yun. 12.5, 25. 18 plus 7, also 25. So, more or less, nevertheless, tama yung ating reactions. Okay? As much as possible, kung determinate trusses, kung equal yung reaction with regards to the applied forces, lalo na kung horizontal, vertical axis, ibig sabihin tama po yung na-compute ninyong reaction. If not, reanalyze your solution. Then, kung equal din yung horizontal forces, applied horizontal forces with the equivalent horizontal reactions, parehas tama pa rin po yung inyong solution. So with that note, we can simply solve this particular problem by, again, the method of joints. Saan nyo gustong mag-umpisa? Saan nyo gustong mag-umpisa? Ano ang condition in method of joints? Start or always start solving at a joint where there are only two unknown member forces. Saan dyan ang may dadalawang unknown na members? Saan dyan? Joint B? Ilang
Yes,
member
sir.
yan? 1, 2, 3, 4. May masosolve ka ba ni isa dyan?
Sir, sa A.
O, it's either A or E. So, gusto natin, may masolve tayo kaagad, diretso tayo sa joint A. Para hindi na ako galaw ng galaw, no? Screenshot nyo na yung figure. Kindly screenshot the figure na lang. So, dito na lang ako. Ano ba to? Naisulat ko naman na yung value. Burahin ko na lang yung solution dito. Recorded naman to. So, no worries. Okay? So, let's us consider joint A. At joint A, assuming all members are acting in tension. What are your members connected at joint A? We have a hinge support at joint A. Identified reaction, horizontal, AH, equal to 0. Downward si AV as identified equal to 9 kilonewton. Members at joint A. Meron tayong AB and AF. Horizontal vertical component, 1 square root of 2. Ito yung sinasabi nating horizontal vertical component and its direction. Ito yung vertical AB. Ito yung ating horizontal AB. Horizontal AB is basically AB times 1 over square root of 2. Vertical AB is also AB times 1 over square root of 2. Magvavary na lang yan depende dun sa horizontal and vertical length ng ating member trusses. So based on this plot diagram, basically that is your free body diagram lang. Oh. What are the forces identified on the horizontal axis? That is, or on the x-axis, your AH, your AB of x, then your AF. Vertical axis, your AV and your AB. Anong pwede nating masolve kaagad? Kung yung horizontal axis tayo magsosolve, there are two unknowns. Tama ba? Tama? So kung vertical, there are only one unknown. So summation forces vertical. Summation forces vertical, what are those vertical forces? We have upward forces positive, AV going down, that is negative, AV. Then AB vertical component, positive, upward. Upward of 1 over square root of 2. Meron pa bang ibang vertical forces? Of course, wala na. AV is 9 kilonewton equal to plus AB of 1 over square root of 2 equal to 0. Simplify, transpose at the other side, 9 over 1 of square root of 2. That is AB. As much as possible, wag nyo na lang i-convert sa decimal kung pwede nyo naman i-express as like this. 9 of square root of 2 kilonewton, or that is 12.728 kilonewton. Though sa quizzes and exams ninyo later on, specify ko na lang doon kung ilang decimal yung inyong final answer. Pero kung ganito, as much as possible, para hindi nag-decrease, increase yung inyong forces sa bawat member, gamitin yung buong decimal places. No? Is it in tension or compression? Tension, compression. Of course, that is in tension. Positive o. Then, summation forces horizontal. Bilisan ko ng konti Equal to 0 to this side, positive. What are the forces acting at the horizontal axis? At joint A, we have AH, we have AF, positive. And also, the horizontal component of AB going to this side, which is also positive. AB of 1 over square root of 2. Equate that again to 0. AH is 0. AF is unknown. AB is identified as 9 of square root of 2 times 1 over square root of 2 equal to 0. Cancel, cancel. AF is simply equal to 9 times 1 transposed to the other side. 9 times 1 transposed to the other side. That is negative 9 kilonewton, which is in compression. Okay? So, saan nyo gusto mag-solve next? So, na-solve na natin si AB at saka AF. Pwede na ba tayong mag-move sa joint B? If we move on to joint B, there are still more than 2 unknown members. So, joint B has member AB, BF, BG, and BC. So, 4 na members yan. Pero na-solve na natin si AB, pero there are still 3 unknown members. Masyado pang mahirap yan. So, dito tayo kay joint F. Moving on to joint F, purahin ko to. Moving on to joint F, knowing that member AF is equal to 9 kilonewton, compression, negative. Then AB is equal to 9 of square root of 2 kilonewton tension. Note again, random yung problem natin ha. Baka sabihin nyo, memorize masyado ni sir yung example niya. Hindi po, random ito. Kayong nagbigay ng member, kayo nagbigay ng load, then yung distances, no? So we can move on to joint F. Tanggalin natin si joint F. Lipat natin dyan. Si joint F, merong vertical, horizontal, then another horizontal member. Okay? Ano yung mga yon? We have member BF. Tama ba? BF, AF, and FG. AF and FG. This is your joint F. Meron pa bang forces identified at joint F maliban sa tatlong yon? Meron pa bang iba?
Wala na po, sir.
Sigurado? How about the applied force? Na dead load, live load na 18 kN. Sasama natin yon. Sama ba natin? Hindi.
Yes, sir.
O, di isama natin yon. Kasama yon. Forces at joint F. Meron tayong 18 kN dyan, upward. So, basically, that's just summation forces horizontal, vertical. Summation forces horizontal. We know that AH is in compression of negative kilonewton. Carry the sign if you don't want to change the arrow or the orientations of your arrow. Carry nyo yung sign. Equal to 0. This side positive. Summation forces horizontal. AF going to the left, negative. Then FG going to the right, positive. Equal to 0. We have identified that AF is negative 9 kilonewton and FG equal to 0. Negative times negative, positive transposed to the other side, which is also negative 9 kilonewton, which is still in compression. Okay? Lagay ko na dito para hindi na mawala. FG equal to negative 9 kilonewton compression. Then, of course, summation forces vertical equal to 0. Upward forces positive. What are the upward forces found at joint F? Those are your applied load of 18 kilonewton upward and the member BF as assumed equal to positive BF equal to 0. Meron pa bang iba? Based on our figure, wala na. So summation forces vertical, simplify, transpose to the other side. Diba? That will now become negative 18 kilonewton, right? So BF is simply equal to negative 18 kilonewton, which is pretty much obvious naman dun sa figure. So yun lang naman yung nakalagay doon. So compression pa rin siya. So BF is equal to negative 18 kilonewton, which is still in compression. Extend tayo saglit, no, kahit 5 minutes. Now, pwede na tayong mag-move on sa joint B. Tapos the rest kaya na mag-solve. Madali na yan. Kasi itong joint B lang naman yung kailangan nating isolve dahil marami masyado yung unknown. So at joint B, we finally solve member AB, which is 9 of square root of 2 kilonewton tension, and BF of 18 kilonewton. So we can finally solve the other two members kasi dadalawa na lang yung unknown natin. Okay? Considering joint B. Considering joint B. Joint B. This is your joint B. Horizontal vertical component, horizontal vertical component. Member AB, BF, BG, and BC. Tama ba? Yeah. Meron bang load sa joint B? Meron bang applied load sa joint B? Meron? Wala? Wala. So, walang applied load. Yan lang yan. Meron na tayong value ni AB na tension of 9 square root of 2 kilonewton. BF of 18 kilonewton which is in compression. So, adopt natin yung sign na negative. Unknown si BG. So, plot your horizontal vertical component. Okay? So, summation forces. Ano ba pinakamadali dyan? Wala naman. Pare-parehas ng bilang. So, summation forces vertical. Okay, vertical. Kasi walang vertical si BC. Para diretso tayo kay BG. Summation forces vertical, upward forces positive. We have AB going downward of 1 over square root of 2. Vertical. Minus BF also going downward. And the vertical component of member BG downward as well. BG of 1 of square root of 2. Meron pa bang iba? Of course, wala na. That is equal to 0. AB downward negative 9 square root of 2 times 1 over square root of 2. Cancel, cancel. Minus BF, carry the sign, that is negative 18 kilonewton. Minus BG times 1 of square root of 2 equal to 0. Simplify, that is negative 9 plus 18 minus BG of 1 of square root of 2 equal to 0. Negative 9 plus 18 is 9 kilonewton. Transpose to the other side is negative 9 kilonewton. Divide both sides with 1 of square root of 2. Negative 1 of square root of 2. BG is now equal to 9 of, tama ba? 9 of square root of 2 which is also in tension. Then, of course, last one is the summation forces horizontal, equal to 0, going to the right, positive. What are the forces along horizontal axis found at joint B? We have AB going to the left, negative. BG going to the right, positive. And of course, the unknown member BC equal to 0. Okay? AB is 9 of square root of 2, 1 over square root of 2, plus BG, positive, 9 square root of 2 times 1 over square root of 2, plus BC equal to 0. Okay? Square root of 2 yan. So, simplify. That is negative 9 plus 9 plus BC equal to 0. Tama ba? Negative 9
Yes,
square root of 2 times 1 over square root of 2 is negative 9 plus 9, 0. So, BC is equal to 0. Kahit di nyo na ilagay yung compression tension, that is still 0. So, walang internal force sa member BC. So, nasolve na natin si AB, BF, AF, FG, BG, and BC. So, on your own, try to practice, continue solving this same problem para makita ninyo, solve the succeeding unknown members. Bale, nakalahati ko na siya, oh. So, kung gusto nyong pumunta sa kabila, do the same solution. apply the external forces identified on the right face of the given truss system, then basically pare-parehas lang naman, no? Question. Eksakto, 12:30. Question.